we're going to try and do today is talk about this process from diagnosing to scaling water technologies, where the barriers are, and how we're really good ideas for surmounting them. But you all literally are seeing these for the first time. And if we don't get it right, there's an enormous cost. So think of yourselves as being in a think tank and an action, focused think tank like the Stimson Center. And, everybody's got their seatbelts on. We're going to rock and roll.
So, hi everyone. My name is Gonzalo Espinosa. I met a few of you during the breaks and during lunch. And I'm a senior product engineer at Esri, and I work on a research and development products, creating prototypes. And my background is on water resources engineering. I did a PhD in the University of Texas in Austin. And here's what I'm going to present: the innovations to address climate solution. So last week, at the end of last week, I had two very interesting requests. The first one was to come and present here in this conference and to be with all of you guys. And the second one was to work a little bit on the floods and the Yellowstone River. As you might all be aware, there was a big flood. Some of the roads were damaged. Part of the Yellowstone National Park is not accessible anymore. And then I read an article at the New York Times that they are deploying $50 million in 2 weeks just to restore 80% of the access to the national park. So this gives me inspiration to the idea of resilience that we want to talk about today and climate solutions. So on one hand, we want to work on prevention. We want to, when we have events like this happen, we want to mitigate the damage. We don't want it to be as extensive that it creates a big problem that we cannot recover from it. Right? But also, the second part is that we want to recover quickly. When we have an event like this, we want to be able to come back as quickly as we can and restore what we have in the past. So how can technology help us address climate solutions? That is the key of my remarks. So I'm going to focus on three things. I'm going to give a few examples of the things that we do as Esri at Living Atlas. I'm going to show the concept of live apps or live applications. And third, and most important, is the Q&A. As Elise was saying, this is a panel, and we want to make it as interactive as possible. So the first project that I want to show is about floods in Austin, Texas. There we're working with the National Water Center that we are forecasting. They are forecasting the river discharge for different river reaches in the US. But also we have different hydraulic models. I heard from a lot of you, we have a civil engineering background. I'm also a civil engineer. So we like models, right? We create a hydraulic models. We know the flood extent and that. But for flood applications, we were talking in this scenario with the firefighter chief or the fire department in Austin. So they don't have a hydraulic engineering background and say, oh, the moment that you generate the hydraulic models with the new precipitation from the National Weather Service, is too late. I mean, the areas are flooded. I deployed the first responders, the firefighters on the ground, and I don't know what roads will be flooded. I don't know which areas to close. I don't know where people they are affected. So what we did was to flip hydraulic models, take the model around and say, okay, let's listen to the people that use it. Because a lot of the hydraulic models that we have, maybe they were developed for planning, not for this type of first responders, right? So in this case, the red dots are fighters or first responders on the ground, and they just drop a pin. So we take the complexity of the models and we make it as simple as possible. And that's one of my takeaway messages. Let's make it as simple as possible. So they go to the ground and they drop a pin. They say, oh, I see water here. If this point is flooded, what else is flooded? So then we have a operation center that is accessing all the points in real time, and they see the flood extent. So then we have a map of the communities that are affected and the rivers or the roads that might be closed. So it's a different way of presenting information. We have all the flood models, the flood polygons, but let's make it accessible in a way that is helpful for the people on the ground. Then Harsh from World Bank showed this slide, the one on the right, because we are partnering with them too. It's a forecast of river discharge. So Al was telling that we have, every year that passes, we have less gauging stations. So now, but we have different models that we can use. We have remote sensing, or we have a forecast of river discharge. So even though we have less information, we can use it to calibrate these models. So now we have information in areas that we didn't have in the past. Some of these river reaches, they never have a river gauge. Maybe we didn't have enough historically long time series that we cannot make projections. But now we have information that we can work. And this information is freely available through web services online. We also have a more detailed model in the US from the National Water Center. But then coming back to my example of the floods in Austin, Texas, I won't tell the chief in Austin that the river will have 3 cubic meters of water flowing per second in a given time, right? So they want to know the flood extent. So we develop all the models to transform river discharge into flood inundation area. We have it on the background. We have it in the behind the scenes. And then we connect all those services to forecast inundated areas instead of river discharge. And then even more, if we take it one step ahead, we map it with the address points from the city of Austin. So then we have the address points that are affected. We know the people that are living there, and the first responders have a clear idea before they go to the ground or what's going to happen or what's happening on the ground. Exactly. Instead of waiting for the result of a hydraulic model, right? Yes. Like a better use of the resources, more tailored to the needs on the ground. Then to the second part of my talk about live apps. I work in the Living Atlas of the World team, and I would like to highlight the living part of the atlas. That means that is information that is live, that is updated frequently, and that you can start using it right now. Jenna mentioned in her talk that sometimes the budget is restricted, or they want to build something quickly with apps that are ready to set up. So the Living Atlas already provides a lot of layers. So the Living Atlas is the foremost collection of geographic information in the world that you can use layers, apps, or different maps for different applications. So these layers are curated, authoritative. They are from recognized sources, international organizations, or maybe or federal organizations like NASA and so on. So there is a data set of layers that you can start using right now just for any application. We have, for example, wind data, the discharge. We have data on droughts, data on air quality, or wildfires. And then we can summarize this data in indicators. For example, we know how many agricultural jobs, if we use data from the agricultural census, might be affected by a drought. So we just intersect the drought areas with information from the farmers. So this type of indicators, this analysis can be on the fly, can be done on the fly, and these cards can be populated every time that you get new information. So you have a time series of how you're being affected. These indicators can be tailored for different applications like SDGs or different areas like flash flooding or extreme heat. Yes, it can be one of the applications. application. Right. So then, just as a summary of my remarks, information has to be easy to understand, like the pin to plot app, dropping points on the ground, and the first responders, they know immediately what areas are plotted. Information has to be meaningful. It has to be robust enough that it provides a solution or information about the problem that we are aiming to solve. And it has to be actionable. And this last part is the most important one. It has to transform on actions on the ground, like the identification of address points on a flooded area. Before that, so how we can address resilience and climate solutions. We know that the spatial data, I mean, I work for Esri, the science software. All the data and the climate is spatial, inherently spatial. So we have to think spatial. Information is live. We get information every day, everything changes, so we have to design applications that reflect that. And the best way to share that information is through online web applications. So my takeaway message is that we need less reports, less PDFs, and more online applications, interactive, that we can share and we can analyze with our users or with different partners. So with that, I leave the place to you, Alex. Oh, this is an example of the evapotranspiration in the Amazon basin. And then I overlay it with the protected areas. So then we can see the role of having an area designated as protected area and how it's being conserved. But also we can see which areas are not being conserved, even though they have the protection framework. But even further, we know who is the managing authority of that protection area, so we can do enforcing or we can follow up with them.
So they're going to pull up the deck, but I want to talk a little bit about this notion of what we think of as innovation, because I think we tend to think about innovation as the technological moments, and they're extraordinary. I am the umpteenth generation of inventors, and I love those moments. But what you're going to hear from us today is a different kind of innovation and a transformational innovation. It's sort of the slow food movement of innovation, right? It's about the diagnostics and making the information available to be actionable. And then what I'm going to talk about is scaling, taking those extraordinary innovations, the existing innovations that we have, and moving them into the supply chain better and faster. And I want to talk about why for Americans that's really hard. We're not so far from Roanoke, who's a history buff in the room. Excellent, you're my hero. I know nothing about history, but I'm particularly moved by the story of Roanoke Island, right? It's close enough. And, you know, they found it. They found it 3 separate times, and none of those colonies survived. And it's easier to find than it is to settle. It's easier to discover than it is to make it part of our daily lives. So what we're going to talk about at CI Race is how we make existing technology part of your daily life better and faster. And I don't mean your daily life on a consumer basis. I mean the entire industrial complex. So I think there must be a clicker somewhere. And I should say, I'm Elise Soli. I'm a science degree. I'm a lawyer, and I'm finishing my MBA as a middle-aged mom. Been a lot of fun to do. Oops. Okay. Yeah. So we're going to talk first about the problem, which you all know. Climate change is functionally a consumption problem, right? The population has outpaced the resources of our globe. And because it's a consumption problem, it's really hard to solve. Nobody wants to give up much. So the working theory is that absent a reduction in our energy usage, and by energy, I mean electrons, fuel, and food, right? Anything that has a caloric or phase change, then we won't be able to achieve our goals. The process problem, though, is rarely talked about, but is actually far worse. So technological innovation, we do not innovate on command well. I wish we did, but if we did, the world would look a lot different. So tech innovation, as extraordinary as it is, and I'm a fan of the American innovation culture, is mostly siloed, stepwise, and competitive. And that means that the best technologies don't always advance. They don't advance in a clear and direct way, and they don't go where they go. So I'm also on the board of the Stimson Center and a co-founder of ACRE, and we went out to our membership and we surveyed them. And we asked them, what are the largest challenges to, they're all climate committed companies. What are the challenges to you achieving your goals? And then we spoke with about 10% of them just to make sure that the answers that we had were the right answers, that we hadn't asked dumb questions and therefore gotten confusing answers. And the consistent candid answers were, there is so much out there, we don't know what to choose. And we're talking about the largest corporations on earth. The largest corporations on earth are not sure which technologies to advance. Think about that. We don't innovate rapidly. Large corporations, those most able to get things in your living room, struggle with innovation. Collaboration is really hard. They don't know who their partners should be. And that's a real, we've all felt this. As anybody have a brother or sister married more than once, right? It's, these things are hard. And government uncertainty is a critical consideration. So what we do, based on all of the data and information that we got and bringing together a number of experts who have worked in the space a long time, we got a group together. I'll talk about the group in a second. And we decided to rank via AI systems. And we'll talk about, there's a human component that's really important. The most readily executable, impactful climate technologies that exist today. And the idea was, hell, let's just tell people what's out there, right? If it's noisy, we can solve for that problem. And then we decided that because some of those solutions have some final technological roadmap work to do. So you have a question. I want to hear what your question is. What does that mean? Yeah. Awesome. Yeah. We're going to talk about the biases. Yeah. Yeah. Yeah, I think as a water utility, you're going to find they're very different than what you expect. We don't go bigger, we go smaller, and we go smaller in a very particular way. But I don't want to suggest that we think our ranking is the only ranking. We think more people should be doing this. The question is not, should we not be trying to move the most actionable technologies? The question is, if you rank the actionable technologies, can you bring corporations that are lagging in deploying capital to deploying capital? And we think there the answer is yes. So then there is a 12-month R&D session. That R&D session is open, and I mean totally open. Any scientist who receives the notice, I mean, there is a limit to the way we can reach out to people, but there is a published notice, and universities are all invited to participate in the open R&D session. This is an all hands on deck approach, and it is open. The technology is allocated on an open basis, and we'll talk about that. But the idea is that session produces a technology roadmap. And then at the same time, the group engages governments to facilitate the scaling and produces a deployment roadmap. So the idea is that if we solve for the 3 problems that were identified, it's too noisy. We don't know how to proceed and to get our partners moving right. And then we don't know how to move through space to scale right, that we might get a few technologies out there faster. All of this is funded by the private sector. So the 3 entities, Spark Beyond leads the AI team, Cambridge University hosts our university engagement effort, the technological deployment team, and the Stimson Center leads on the engagement campaign. So this is a differentiation slide. It solves for the problems. We identified the problems and the absence of capital moving into the space, and I promise you, we worked hard to solve for it. This is a slide that talks about how differentiated it is. So essentially, by bypassing small increments of capital, going to the national labs, going to the venture community, scaling with private equity community, we end up with a direct supply chain ability, and it's a fitted supply chain. So the companies that choose the technology that's right for them, and they make a commitment to scale, and we claw back the technology if they don't scale. This is our launch process. Hopefully we'll be starting at the end of the day, at the end of the year. There's a budget. I promise you that, but I want to go to the ranking process because I think the ranking process answers a lot of questions. I'm going to go to an image slide first. AI is subject to bias, right? The systems of collection are necessarily determined by what we've thought about and how we talk about them. And that's a real issue for us. We don't like getting caught in biases. And our significant concern at the beginning was, are we sure these technologies are better, or are the people just louder, right? And if the people are just louder, that's not where we wanted to be. So we made a decision that is a limiting decision, but we're comfortable with this limiting decision. So what this slide shows is in turquoise publication, the green patent, and then this is news. And those 3 slides together, for anybody who's worked in this space for a long time, as I have, because I'm old, you know what this means, right? That publication patents are correlated, and when you get a news bump at the end, there's only 2 possibilities there. It's essentially binary 99.9% of the time. The binary nature is either it blew something up or it succeeded. That's the only reason it makes the news. And so you end up with a really good indicator on what the structure is there. So by searching for that, we were able to at least come up with technologies where we thought that there was this noise around them, and we wanted to make sure that noise was real. So the way that we addressed whether the noise was real was to go back and make sure that no technology made our list unless it had been subject to 3 independent reviews. So the technologies were effectively validated, and only then do we bring them to our sponsor. We ask our sponsor to fund the final stage of the R&D, to fund the R&D session so that we get the technological roadmap and then the government engagement roadmap. So at the end of the day, a leading corporation commits its supply chain to scale a technology that we have identified as actionable and likely to have a significant global benefit, going through the same analytics you have. That process requires them to commit to provide the technology to competitors at a sub-profitable rate for the developing world, including with a licensing program to the developing world. and to move it forward with alacrity. If they won't accept those conditions, then they don't receive the technology roadmap, the access to the Cambridge hosted team, or the engagement agreement that the Stimson Center worked through. I think it might be helpful just to see what we identified on an exemplary basis for technologies, because they're all unusual. This technology for PV, solar PV, film or tiles, makes it on site. You don't mine in one place, move the material that's manufactured to another place and send it around the globe. You send this to the manufacturing facility, and it actually creates solar PV in place where you have silicates. And this is a shipping example. I'm a hydrogen person. I've worked in hydrogen for 20 years. I would like to see SOFCs everywhere using liquid hydrogen, but we are not there yet. So right now, the transportation process is significant, because what we found is that scope 3 emissions, which are 95% of the emissions, are really about the supply chain. Yes.
Question about this device here. Can you design the panel on site? And how? And that, I'm kind of blown away by this. How many panels can you produce in a day? And how much does it cost to produce one panel? Right. And who makes these machines? Okay. And how many of them are there in the world? 40 or 50?
How about talk a little bit about the sponsors? unless if you want to. If you don't, well, that's okay. But include the comments that that you heard of saying, "Man, I would do this just to be in the same playground."
You know, we've had some wonderful responses from sponsors. We've had sponsors say to us, we go on junkets to visit every university on earth. You mean you're going to put them in one room to work on a project that integrates into our supply chain? We would pay the sponsorship fee for that. And the sponsorship fee is designed to engage diversity. What's really important is that sponsorship fee has some requirements that not only do the universities need to be represented, this is not just MIT and Stanford, and I say that as an MIT baby, but it is designed to make sure that as many voices as want to be in the room can be in the room. And for some universities, land-grant universities in the United States, this is true, and it's true of the world's universities. They could not afford to be in the room unless there's. Go ahead, please.
I had a question about the bottom line there where it says lowest CO2 value equivalent. So I'm honing in on the word value. You just mentioned diversity as a quality. And so when you, if you would just want to look at metric tons CO2 reduction or offset, that's one thing, but there's so many other things that could fit into value. And I'm curious what else might be included there.
Super. This example is just to be really easy because everybody's held an aluminum can. And aluminum cans, the aluminum can that you pay 5 to 10 cents for, Coke pays 5 to 10 cents for, with 1.9 billion of them a year, is because aluminum mining, transportation, and production is largely subsidized. And subsidized for all the right reasons. You need me to stop, right? Are you sure? Okay. The reason it's subsidized is because it's really important to have a mining industry for some nations. It's really important to have a transportation industry for others, so that the cost is not the actual cost, and it's certainly not its externalities. What we do in the third part of our ranking after we use AI, there's a human cost benefit analysis that comes in, focuses on scope 3 emissions and other impacts. We have 18 criteria. We're happy to share them. And there we look at the effect of the entire system, not only on carbon, but on ecological values and on water use and on waste. And what we try to do is to eliminate the effect of perverse subsidies and shipping things around the world under the working theory that if you manufacture locally, you care about what's in your backyard, and you're more likely to have a safer, more inclusive, more functional process than if it's being manufactured halfway around the world or halfway around 3 parts of the world. So thank you.
Why big corporations?
We are loved not to have had it be the largest corporations on earth, but we could not figure out how to get the supply chains aligned as quickly as we wanted to. This is about the rapid deployment of existing technologies that are currently being missed, right, and are sort of stuck in this inexorable process of slow growth and conversion and buyouts. And we felt that if we invited the supply chains to the table and said, this is going to come at a cost to you, and the cost is going to be that you have to sponsor the tail end of the process. You have to make commitments to move this technology forward, and you have to integrate it in your supply chain at a lower cost to the developing world and on an inclusive basis. That was good enough to get the technology out there fast. Go ahead. So we are in the process of identifying technologies, and we don't want to do that until we have are fully funded. So we did it on a test run basis, what I would call a minimum viable product basis. And we feel really good about that. I think we know we can do this. It's subject to 2 independent reviews, but we wanted to wait until we had our full philanthropic funding, because we're not making money at this, and also till we had our first 3 sponsors, so that there was full engagement around the ranking and everybody could see the process, because we felt if we delivered it as a magic box that we would end up with some folks who understandably want you to start again to demonstrate the process, and then we would be doing it twice. So we're 3 months to completing the AI ranking, part of the ranking. In fact, there's 500 years of AI technology, person years of AI technology behind this. And it goes out to, again, a full independent review. So the Spark Beyond team had been working on this for 18 straight months. And that's how we got to the back and forth on the process and getting to the end. So we think 90 days is our estimate, and we're going to stop at 100 technologies. That doesn't mean we don't think there are more than 100 technologies. It means that we think that 100 technologies is more than enough for us as a not-for-profit entity to spend, a committed period of time moving these technologies forward.
Um, yes, sometimes there are different gaps that we have to solve. Maybe one of them is the how to sell the complexity that it takes. In a lot of organizations, what I've seen is that they want results quickly, but we have to build that part, right? So it's something like building a bridge. You are creating something. And also, the second part, or maybe the biggest one, is the maintenance and who takes ownership of what. Because I can build a lot of prototypes and they can be very helpful. But at the end of the day, someone has to maintain that to make sure that it works, that it's compatible with new services or new technologies, but also that that is properly maintained, and also that the institution that gets, even if they develop the application or if we develop the application for them, that they have the expertise to maintain it and to continue with it, not to pull the plug. So that was my question to Harsh, but he's not here anymore. That sometimes in work at the bank, they have project-based solutions for application. And my question was that, okay, so how can we go beyond the project-to-project basis and generate knowledge and use that knowledge from one project to the next one? Instead of pulling the plug and start it again in the next cycle, how we can continue with what we have. Yes, and we have done that. For example, with the national water model, it started as a national interoperability experiment at the University of Texas. So we were a bunch of PhD grad students working on that. And we went to Tuscaloosa, where they had the National Water Center. And we demonstrate that we can forecast river recharge recharge in the U.S., river discharge in the U.S. for 2.7 million of river reaches for the next 10 hours. And then after we demonstrated, well, there was through a NSF grant. Now the NOAA and the National Water Center took ownership of that and continue the development of it. And now it's widely known and used in the US. So yeah, that's a way to talk to the right partners. But first, building something that you have to demonstrate that it works. I think, I forget who mentioned that. I think it was Kumar in the previous presentation. Oh, it was Kumar in the previous presentation. That you build something that works, you show that it works, and then you can have a more meaningful discussion on how to proceed and how to go next. So when we talk about municipalities, also there are different type of municipalities. For example, Austin, they're very flood aware. They have a big budget, different to the municipalities in East Texas, right? So it's a balance where the big cities or the urban areas, they have the means and they have the ways of doing that. But also at the state level, you can use those experiences to replicate in areas that maybe don't have the expertise or the local knowledge. That will be through the state. Yes, with both, with PERC and Army Corps. So we have with dams, they were using national water model. Actually, it was one of the first things that I did in the DC office here with Esri. The people that work at PERC, they wanted to know the inflow in the dams, to know if maybe the spillway was going to be open or they. So they have the forecast from us, well, from the national water model. Now they connect the forecast into a dashboard so they know if one dam is at risk of the risk of overflow. Yes. Yes, that part I need to talk to my colleague, but yes, I believe it does. How you get that? Oh, to everybody. That's a good question. So, yes. So it's from events like this, from different, for example, talking to the chief department in Austin, talking to policy people, I think is key. And in a language that that it's common for all of us. I can spend hours talking about hydraulic models and equations and all that, but I always try to stay away from that, unless I'm in a scientific conference or something. So I think what I like about the Esri and MAMS is that they tell a story and they tell it quite well, because everybody has like the visual impact of that. Oh, I get the point. I get where the plot polygons are. So yes, that's how we do the outreach. Yes. It depends. It's made through the state government or through local government, but also by request. Because if we build something and say just start using it, I think it has to be like a partner that wants to do it and wants to take ownership of that. And related to your previous comment, there are a lot of institutions related to water in the U.S. at the federal level. So there is also that we have to distinguish what's the mandate of whom. For example, USGS deals with historical data, NOAA deals with forecast. So there is something in between that is now, that is the National Weather Service. So there are different ways that, and that's in the US. If we go to other parts of the world or the global south, I mean, it's the gray area is even larger. But I like the concept that Elise, that you mentioned about the minimum viable product. In this case, is pin to flood is like is the minimum. What's the minimum that they can do? Just drop a pin and get a flood polygon. They don't get 1,000 buttons they can select or 1,000 options. Just drop a pin. In this case, in Texas, yes. So it's not longer a prototype. The state of Texas is deploying that for the whole state. And we did it with a 10-meter elevation model. And now they are regenerating the flood polygons, the ones that we have using LiDAR. So better spatial resolution. Yes. So I'm still involved because the flood polygons live in ArcGIS Online, in Living Atlas. So there is a way, or they live in their ArcGIS enterprise. So we share the expertise, we give training, or we help them set up the system. I think it's important who owns it. Well, it can be open source, it can be shared, but someone, for example, I think it's Texas or Texas, only if the state organization in Texas, who is the owner, changes the flood polygons, that's what I mean with ownership. Not that it's something that is hidden, but something that they say, okay, we need to refine this model in this area, and they do it, and that's the official flood polygon that they are pushing. So that's what I mean with ownership.
Yeah, one last question.
So that is a hard question that none of us want to answer, right? No, it's leadership. Yes, they come and go. It changes, but if we are able to demonstrate the added value that they are having to their citizens, like flood protection or first responders, it's, I would say, not easy to convince them. But if you show the added value to one administration, you should be able to show it to the next one. I mean, it's a challenge. You might be repeating a few things, but that's how it works. It's part of what we have to do.
Okay, one last comment about CI race, and that is, and you might be thinking, why would any giant corporation want to sponsor this compared with what they have to give up? Remember, no patents. They can't take it like, remember in the 60s, people would, there was a rumor about a carburetor that got 100 miles to the gallon, and GM bought it and put it on a shelf. Can't do any of that stuff. Why would they want to even play in this game? And think about the idea of how do you change the idea about scale. Scale is the key here. If I have a pizza that's 12-inch, CI Race creates a pizza that's 20 feet because it's all global in scale. that's why they want to play, because you increase it where it becomes almost infinite to where they can actually make money. It's all about how you scale. All right, so thank these two for very engaging